You are 63 years old. You just finished a dinner plate with a full piece of grilled chicken breast, a food you have eaten your entire life, a food you have always believed was pure fuel for your muscles. And yet somewhere between your stomach and your bloodstream, most of that protein is quietly failing to become what you think it becomes. It is not being wasted in some obvious dramatic way. There is no pain, no warning sign, nothing you would notice on an ordinary evening. It is simply passing through you, partially broken, partially unlocked, unable to deliver the one specific amino acid your muscles are waiting for. And this single hidden failure, repeated meal after meal, year after year, is one of the most overlooked reasons people lose strength, lose muscle, and lose independence after 60, even while eating what looks like a perfectly reasonable amount of protein every single day. It shows up nowhere on a routine checkup. It does not hurt. It does not announce itself. And yet it may be quietly shaping how strong you feel getting out of a chair 5 years from now. Today I want to walk you through exactly what that protein is, why your body slowly stops digesting it properly, and what the actual science says you can do about it, starting from the chemistry all the way down to the plate. And by the end, you will never look at a simple dinner plate the same way again. Before we go further, if you are someone who wants to understand your body instead of just guessing at it, this is exactly the kind of content this channel, Smart Psychology, is built around, so consider subscribing. Because we are about to get into the real mechanism, not the surface level advice you have probably already heard 100 times. Let us start with what is actually happening inside your stomach as you age, because this is where the entire story begins. Your stomach relies on a population of cells called parietal cells, and their job is to manufacture hydrochloric acid, an extremely strong acid that sits at a pH between 1 and 3, roughly the acidity level of battery fluid. That acid is not just there to kill bacteria, it plays a second, quieter role that most people never learn about. It activates an enzyme called pepsin. Your stomach does not produce pepsin directly. It produces an inactive precursor called pepsinogen, and pepsinogen only converts into functional pepsin when it meets that highly acidic environment. Pepsin is the enzyme responsible for the very first mechanical and chemical step of protein digestion. It unfolds the tightly wound structure of dietary protein and cuts it into smaller fragments called peptides. Fragments your small intestine can later break down further into individual amino acids that actually enter your bloodstream. Without enough acid, pepsinogen simply sits there, inactive, doing nothing, and the protein you just ate moves further down your digestive tract, still folded, still bundled together, still largely unusable, to the muscle tissue that is waiting for it. Here is the part that changes everything about how you should think about your own aging body. Research on gastric physiology has repeatedly shown that acid output from those parietal cells declines with age, and a condition called atrophic gastritis, where the stomach lining thins and acid-producing cells are gradually lost, becomes dramatically more common after 60. With some studies estimating it affects roughly a quarter to a third of older adults to some meaningful degree. This is not a rare disease confined to a small unlucky group. It is a slow, largely silent shift that many people experience for years without ever being told about it, often mistaken for ordinary indigestion or simply written off as part of getting older. It is compounded further by one of the most commonly prescribed classes of medication on the planet, proton pump inhibitors, drugs that deliberately suppress stomach acid to treat reflux and ulcers, and which are used by a very large percentage of adults over 60, often for years at a stretch without regular reassessment. When you combine a naturally aging stomach with a medication whose entire purpose is to reduce acid, you get a digestive environment where pepsin activation is chronically impaired, where iron and vitamin B12 absorption also quietly suffer since both depend on the same acidic environment, and where the protein sitting on your dinner plate, no matter how much of it there is, cannot be efficiently unlocked into the amino acids your muscles are depending on. Let us take a moment to talk about what protein actually is at a structural level, because this makes the whole mechanism click into place. A piece of chicken breast is not simply a bag of loose amino acids waiting to be absorbed. It is a tightly folded, three-dimensional structure, strings of amino acids twisted and bundled together into a shape that your digestive enzymes have to physically take apart, one peptide bond at a time. Cooking denatures that structure somewhat. It unravels some of the folding, which is part of why cooked meat is generally easier to digest than raw meat, But denaturation from heat is not the same thing as digestion. The peptide bonds holding those amino acids together are still fully intact after cooking, and only enzymes, primarily pepsin in the stomach, followed by trypsin and chymotrypsin in the small intestine, can actually cut those bonds and release usable amino acids. If the very first enzyme in that chain, pepsin, is running at a fraction of its intended activity because there is not enough acid to activate it, the entire downstream digestive cascade starts from a weaker position, and the small intestine ends up trying to compensate for a job that should have already been partially completed higher up. Now let us connect this directly to muscle, because this is where the story stops being abstract biology and becomes something that actually explains why strength and mobility change as people get older. Muscle tissue is not static. It is constantly being broken down and rebuilt in a cycle called muscle protein turnover, and the rebuilding half of that cycle is called muscle protein synthesis. Every time you eat a meal containing enough usable amino acids, you trigger a temporary spike in muscle protein synthesis, a window where your body actively repairs and builds muscle fibers using the material you just supplied. Researchers Douglas Patton-Jones and Elena Volpe at the University of Texas Medical Branch spent years studying exactly how this process changes with age, and what they documented is something now referred to in the scientific literature as anabolic resistance. In simple terms, an older muscle requires a larger dose of usable amino acids to trigger the same muscle building response that a younger muscle achieves with a smaller dose. A person in their 20s might fully activate muscle protein synthesis with roughly 15 to 20 grams of high-quality protein in a single meal, while a person past 60 may need somewhere closer to 35 to 40 grams of that same quality protein just to reach the same threshold. And studies comparing young and older adults, given identical protein doses, have consistently found a blunted synthetic response in the older group, even when the amino acids were fully available in the bloodstream. This is where the picture becomes genuinely alarming, because anabolic resistance and reduced protein digestion are not two separate problems, they are the same problem compounding itself. If your stomach is already struggling to convert the protein you eat into usable amino acids, because of declining acid and pepsin activity, and your muscles now require a significantly larger dose of those amino acids just to respond at all, then a completely normal serving of chicken or fish or beef, the exact same serving that worked perfectly well for you at 30, may now be delivering far less than the threshold your muscles actually need. You are eating protein. Your brain believes the job is done, the plate is empty, but your muscles never even received the signal to rebuild. This is not a motivation problem. This is not a matter of eating more willpower. This is a measurable shift in your digestive chemistry meeting, a measurable shift in your muscular biology, and almost nobody explains the two together in the same conversation. If this is the first time anyone has connected these two mechanisms for you, that is exactly the gap this channel exists to close. So if you find this useful, take 30 seconds right now to like this video. It genuinely helps more people find explanations like this, instead of the generic advice that dominates most nutrition content online. Let us talk specifically about which amino acid is doing the heavy lifting here, because not all amino acids trigger muscle protein synthesis equally. The amino acid leucine acts almost like a switch. It directly activates a cellular signaling pathway called mTOR, which is the primary trigger that tells your muscle fibers to begin the building process. Research from Stuart Phillips and his team at McMaster University has repeatedly shown that hitting a leucine threshold of roughly 2.5 to 3 grams in a single meal is what flips that switch. And below that threshold, muscle protein synthesis barely increases at all, regardless of how much total protein you technically consumed. To put that in concrete terms, a standard serving of chicken breast contains roughly 2 grams of leucine. A serving of whey protein isolate at 25 grams of total protein contains closer to 2.5 to 3 grams of leucine, and a typical serving of collagen contains almost none. This is exactly why the protein you never fully digest after 60 becomes such a critical issue. Because if pepsin activity is impaired and the protein sitting in your stomach is not being efficiently broken down, the leucine trapped inside that protein structure may never actually reach your bloodstream in a large enough concentrated dose to cross that mTOR activation threshold, even if the total gram count on your plate looks perfectly adequate on paper. There is another layer to this that almost nobody talks about, and it involves a protein that has become enormously popular in the last several years: collagen. Collagen supplements and collagen-rich foods like bone broth are marketed heavily toward older adults for joint health and skin appearance, and while there is legitimate research supporting some of those specific benefits, collagen is structurally a very poor source of the exact amino acid we just discussed. Collagen contains almost no leucine. It is instead dominated by glycine, proline, and hydroxyproline, amino acids that are useful for connective tissue, but essentially useless for triggering the mTOR pathway. If someone past 60 replaces a portion of their actual muscle-building protein, chicken, fish, eggs, dairy, with collagen, believing they are supporting their muscles, they may unintentionally be making their anabolic resistance problem worse rather than better, because they are consuming volume without consuming the specific trigger their muscles now require in higher amounts than ever before. There is also a gut microbiome connection here that recent research has started to take seriously, something scientists are now calling the gut-muscle axis. Just as your gut bacteria influence inflammation and mood, which we have discussed in earlier videos on this channel, emerging studies suggest they also influence how efficiently your body responds to the amino acids you do manage to absorb, with certain bacterial populations, including species like Akkermansia muciniphila and Faecalibacterium prausnitzii, linked to lower systemic inflammation and better preserved muscle mass in older adults, while an imbalanced microbiome appears to correlate with worse outcomes in sarcopenia, the clinical term for age-related muscle loss. Some of the short-chain fatty acids these bacteria produce, particularly butyrate, appear in early research to influence muscle metabolism directly, adding yet another layer to how deeply your digestive health and your muscular strength are connected. Sarcopenia itself is not a minor cosmetic issue. Research estimates that adults can lose somewhere between 3 and 8% of their muscle mass per decade after 30, and that rate accelerates noticeably after 60, eventually affecting balance, mobility, fall risk, and the ability to live independently in your own home. The protein digestion problem we have been describing is not the only cause of sarcopenia, but it is one of the most fixable, and almost nobody frames it correctly for people who are actually living through it. Before we move into what to actually do about this, it is worth understanding how much protein the research suggests older adults need across an entire day, because the official guidelines most people have heard of were never designed with this problem in mind. The standard recommended daily allowance for protein sits at roughly 0.8 grams per kilogram of body weight, a number originally calculated to prevent outright deficiency in a healthy young adult, not to preserve muscle mass in an aging body dealing with reduced digestion and anabolic resistance. A body of research summarized by groups like the PROT-AG study group, which brought together protein and aging researchers including Wolf and Bauer, has argued that older adults actually need somewhere closer to 1.2 to 1.6 grams per kilogram of body weight per day, nearly double the official minimum, simply to offset the combined effect of reduced digestive efficiency and a higher per meal threshold for triggering muscle protein synthesis. For a person weighing around 70 kilograms, that is the difference between roughly 56 grams of protein a day under the old guideline and somewhere closer to 90 to 110 grams under the updated research, spread deliberately across multiple meals rather than consumed all at once. It is also worth mentioning that simply eating more and more protein past a certain point does not keep producing more benefit. The relationship is not linear. It follows a pattern of diminishing returns. Once you cross the threshold your muscles can actually use in a given sitting. This is precisely why quality and digestibility matter as much as raw quantity. Doubling your dinner portion of poorly digested protein will not fix an activation problem happening at the level of pepsin and stomach acid. It will simply mean more undigested material moving further down your digestive tract, sometimes contributing to the bloating, prolonged fullness, and occasional discomfort that many older adults quietly experience after high-protein meals and simply attribute to getting older, rather than to a specific, identifiable digestive mechanism. If you regularly feel unusually full or sluggish for hours after eating a protein-heavy meal, that sensation itself is sometimes a subtle signal worth paying attention to, not a diagnosis, but a pattern worth mentioning to a doctor, alongside everything else we have covered today. So what does the actual science suggest you do with all of this? The first practical step involves how you eat protein, not just how much of it ends up on your plate. Chewing thoroughly matters more after 60 than it did at 30, because mechanical breakdown in your mouth reduces the workload your already weakened acid, and pepsin system has to handle further down the line. The second step involves protein quality and digestibility, favoring proteins that are naturally easier to break down and unusually rich in leucine. Whey protein stands out specifically here. It is fast digesting, extremely rich in leucine relative to its total protein content, and research from Padden-Jones and other groups has shown it triggers muscle protein synthesis in older adults more efficiently gram for gram than many whole food protein sources. This does not mean whole food should be abandoned. Eggs, fish, Greek yogurt, and lean cuts of meat remain excellent choices. It simply means that for someone concerned about hitting that higher anabolic threshold, a whey protein serving alongside meals can help close the gap that reduced digestion creates, without requiring you to eat an unrealistic volume of food at every sitting. The third step involves quantity and distribution across the day, rather than concentrating protein into one large evening meal, the pattern most people fall into without ever thinking about it consciously. Since anabolic resistance means you need roughly 35 to 40 grams of high-quality protein per meal to maximize the response, spreading that amount across 3 meals rather than saving most of it for dinner allows you to trigger muscle protein synthesis multiple times per day instead of just once, which appears in research to produce meaningfully better outcomes for muscle preservation over months and years. The fourth step involves pairing protein intake with resistance exercise whenever possible, because Phillips and other researchers have shown that mechanical loading of a muscle, even something as simple as body weight movements or light resistance bands, appears to sensitize the muscle to the amino acids arriving afterward, effectively lowering some of the resistance that anabolic resistance creates. The fifth step, and this one requires a conversation with an actual physician rather than a video, involves reviewing any long-term use of acid-suppressing medication. Because while these medications are genuinely necessary for many people, their long-term impact on protein digestion is a legitimate topic to discuss with a doctor, rather than simply accepting it as an unavoidable side effect of aging that nobody is allowed to question. A sixth consideration worth mentioning involves the broader eating environment surrounding your meal, because your nervous system plays a direct role in how much acid your stomach produces before food even arrives. Eating in a rushed, distracted, or stressed state activates your sympathetic nervous system, the fight or flight branch, which actively suppresses digestive activity, including acid secretion, while eating slowly, calmly, and with attention to the meal itself allows the parasympathetic branch, sometimes called rest and digest, to dominate instead, priming your stomach to produce acid more effectively before the first bite even lands. Some people also find that mildly bitter or acidic foods eaten shortly before a protein-heavy meal, a small portion of leafy greens, a splash of vinegar-based dressing, or citrus, appear anecdotally and in some smaller studies to stimulate digestive secretions. Though this is an area where individual responses vary considerably, and it should be treated as a gentle supportive habit rather than a guaranteed fix for a physiological decline in acid production. There is one more piece worth mentioning, tying back to something this channel has covered before, and that is hydration and the timing of meals relative to your digestive rhythm. A well-hydrated stomach with adequate time between waking and a large protein-heavy meal tends to handle digestion more smoothly than a rushed, dehydrated first meal eaten under stress, and while hydration alone will not reverse declining acid production, it supports every downstream step of the process we have described, from enzyme activity to nutrient transport across the intestinal wall. Let me bring this back to where we started. That plate of chicken sitting in front of you at 63 years old is not useless. Your body is not broken. This is not a story about decline being inevitable and unstoppable. It is a story about a mechanism, a specific, measurable, correctable mechanism involving acid, pepsin, leucine, and a threshold that shifts as you age. Once you understand that the protein itself is not the problem, but the unlocking of that protein is, the entire conversation about muscle loss after 60 changes from something vague and discouraging into something concrete and genuinely solvable. You are not fighting your age, you are working with a system that simply needs a slightly different key, delivered more thoroughly, more consistently, and in a form your current digestive chemistry can actually use every single day going forward. Every meal from tonight onward is a fresh opportunity to work with that system, rather than quietly against it. And none of the steps we covered today require expensive supplements, extreme diets, or hours of extra effort. They simply require knowing where the actual bottleneck sits, which, for most people over 60, has never once been explained to them in plain language, in a single conversation, from stomach acid all the way through to the muscle fiber, actually rebuilding itself while they sleep, quietly, every single night, whether anyone ever explains the process to them clearly or not, starting today and every day after. If this changed the way you think about your own plate tonight, that is exactly why this channel exists. So subscribe to Smart Psychology. Share this with someone in your life who is over 60 and still eating protein the same way they did decades ago. And I will see you in the next one, where we go even deeper into the biology, hiding behind the habits nobody questions.